I'm going to be looking at how to set up blend shapes within Apex. In this case, I'll look at a manual setup for this. I'm not going to go through the auto rigging system, as the auto rigger node should work correctly with this setup in any case. So I can go through my setup, and first we'll have my mesh, and this will be Tommy. I've created a skeleton to deform this mesh. This skeleton has no real functionality. The reason for the skeleton is that we need it to store information, and it will be needed for our Apex rig to function correctly. Essentially, we will need to control our shapes, and the sliders for the shapes will be part of the skeleton. I have added weights to the rig, so the rig will be deformable. The weighting is completely and utterly worthless, and the deformation is pretty ugly. So this will give me my basic rig, and after I've made the rig, I'll want to add some shapes to it. Before I add any shapes to the mesh, I want to separate the mesh. I only want a single piece of manifold geometry. So for Tommy, I'm separating all of the clothing and the eyes from the body. In this case, I'll be adding the shapes directly to Tommy's body. This is something which is primarily necessary for export, and it is something which we need to pay attention to. And this is because Houdini is different from most other 3D software. In most software, each individual mesh is actually an individual mesh. You will not have multiple different meshes stored in a single mesh at the same time and have them represented as separate meshes. We should note within Houdini that when we have a geometry node, that the geometry node at the object level is actually the geometry, and that everything within this geometry is a single mesh. The majority of 3D software does not deal with geometry in this way, and we need to keep in mind that when we are working within a geometry node, that the geometry which we are dealing with, even when we're separating it, is a single piece of geometry and a single point cloud. It is not fundamentally defined as separate pieces of geometry. This is a very powerful and flexible setup and gives us a lot of things which we can do within Houdini, but it does complicate export specifically where point numbers are important. If I was to export Tommy, I would want to specify that each of my major components for Tommy is an individual mesh. So I would want the eyes to be an individual mesh. I would also want the teeth to be an individual mesh, as well as the shirt and the pants. So we will need to actually add information to each of these items to specify that they are an individual mesh for export. If we do not deal with this carefully and do not pay careful attention to this, we may have a change of point numbers between the version of the geometry which we have in Houdini and the version of the geometry which is imported into our target package. This can lead to blend shapes breaking and not functioning correctly. Because of this, I'm separating my mesh so that I have a single piece of manifold geometry, and I'll add my weights to this individual mesh. This is followed by an issue which relates to Tommy specifically. This is fundamentally important for the modeling of the shapes, and it's something which I generally try to avoid for a game rig in any case. And that is the construction of Tommy's body actually has two separate meshes, so the body is not actually a technically manifold geometry. So I can select primitives within Tommy's mouth, and I can shift these, and we should see that we have a split along the lip. This is not something which I would want to have in any exported mesh. This will also make it very hard to actually modify the mouth. To fix this, I'm using a fuse node. The fuse has a very small tolerance. These points all share the same space, which means that they should still snap correctly. I'm actually duplicating the fuse node in the setup, and this is something which I probably shouldn't actually be doing, but it's not really important here. I then have a set of blend shapes that I'm creating. These are mouth shapes, and they're extremely ugly, and they aren't set up to blend correctly, but they will give me blend shapes to set up an interface with. Essentially, this should be enough to create a basic setup. To make this a little bit more consistent, I will bypass the second fuse node, as that's not really needed. So I've created the blend shapes, and these are being passed into the blend shape node. I'm not actually going to be using this node for anything other than display. This is useful for testing the blend shapes, and if I was not exporting the rig, I could use this with a standard KineFX rig, but I will not be using this for Apex. I'm now going to merge my shapes with my existing mesh. In order to keep this neater, I'm going to use a separate branch. I'm going to duplicate the object merge node where I'm referencing my body. I will then need a character blend shapes add node, and this node will be connected to my object merge node. This node will give us attributes to register our blend shapes on our geometry. Essentially, this node is used to define blend shapes for export, but we also need this in order to create blend shapes for Apex. When I use this node, I get an error. This error will say that we do not have a primitive name. In order to define a mesh for export, we need to give the mesh a name. This is what will define the mesh when we import the mesh into another package. So all primitives with the same name will become part of a single mesh, and most of the packages that we import this mesh into will treat each mesh as an individual item. To assign this, I can use a name node. In the name node, we'll be specifying the primitive attribute. So here I could give this the name Tommy. This primitive name is what will be used to specify our geometry, and all primitives with the same name can be thought of as a single piece of geometry. This, however, will not work for the entire rig, so I'll do this at the start of my network, and I'll do this directly after my Tommy geometry is imported. Tommy has groups for all of the geometry, so we can name the geometry based off the groups. For this, I will use the name node. However, in this case, I'm going to use a preset for the name node, and that will be name by group. In this node, I'm going to update the group mask, and I'll set this to asterisk. This means that the name attribute will be exactly the same as the name. The name will be a primitive attribute. This node is basically identical to the name node. This preset just has name from group activated, and it has no namings added by default. I can test this within my geometry spreadsheet. Here we'll look at the primitives, and all of the primitives should now have a name attribute. And what we require here is for every single primitive within this mesh to have a name. So now I have my characters mesh, and this mesh is specifying the body. And we can now add our shapes to this mesh. Our shapes will be stored as packed geometry, and we want to be able to add them all to this mesh. To merge multiple meshes as packed geometry, I'll use a merge packed node. This will take multiple inputs, and it will store the inputs as packed geometry. So I'll select all of the sculpt nodes where I'm creating the shapes, and I'll connect the inputs to this node. For the shapes, I'm using basic sculpt node, and these allow me to do basic modeling. We can examine the merge packed node. In this node, we have a section where we can name our inputs. By default, the packed geometry's name is set by the node's name. We can, of course, update the names here if we want to. I can now examine my packed geometry. Under the primitives, we should have 4 pieces of packed geometry, and the names of these should match the names within our merged packed node. We should note that these names are important, and we will need to use them later. We can isolate individual pieces of geometry using a delete node. In this node, I can specify a packed primitive. I can then delete non-selected. I also want to specify that I'm deleting packed geometry. This will allow me to isolate geometry within the packed primitives. Another way to isolate the geometry would be to use the folder unpack node, and this will allow us to specify geometry to unpack. In the character blend shapes add node, I can specify that the mesh that I want to work on will be the body. This is not always necessary, but it is generally good practice. I can now reassemble all of the meshes to create my character. I'm going to reference everything that I need with the object merge nodes. So I'll make a couple of duplicates, and I'll have 3 object merge nodes. I want to reference my network with the blend shapes. I can reference the character blend shapes add node, but I prefer to have a specific node to reference, so I'll get a null. And I'll call this null shapes. I can now reassemble the rig. First I'll get the geometry for my eyes as well as the clothing. Currently I'm referencing this with a null called other, which is not good naming, but it is good enough for an example. In the next object merge node, I'll reference the shapes. That will give me the characters mesh. I will also need a reference for the skeleton, as the skeleton is necessary in driving the shapes. I'll merge the results of the 2 object merge nodes for the character geometry. I will get a warning here, and that's because my other meshes do not have blend shapes. This is not really an issue. Next, I'll need attributes to drive the shapes for my mesh, and these attributes will need to be added to my skeleton. We do not necessarily have to add them to the skeleton, but if we want to export the animation, these will need to be part of the skeleton. I'll add the first attribute with an attribute create node. These attributes will need to be detail attributes. This attribute will need to have the same name as the packed geometry for the shape, so I can copy my first shape name. In this case, it will be lip down. So that's how we'd create these with an attribute create node. I do, however, find this method of working a little bit awkward, so I generally prefer to create the attributes with an attribute wrangle node. The attribute will be a float attribute, and in this case it will be called lip down. I'm going to want to have a float slider, so this will be set with a chf function. I'll also give the slider the same name as the shape. I have 4 shapes, so I'll duplicate this line 4 times. I should then rename all of the attributes and sliders so that the names match up with the rest of my shapes. I can then add sliders for the controls. I will need to make sure that these are all detail attributes. I can now test the blend shapes with the character blend shapes node. we should keep in mind that this node is just a display node. It will literally break the exports, so you should not use this in a rig where you want to maintain any attributes, and you should not use it in a rig where you want to maintain the blend shapes. You should never use the outputs for this node if you want to export a rig. I can test this, but this is not working. And that's because I didn't name my attributes correctly. This is your classic copy and paste error. I'll rename these nodes quickly. I'm now able to drive my shapes with the sliders. This will give us some very ugly shape animation, which is very poorly blended. But that has more to do with my modeling than the setup, and the setup is working correctly. So this is the basic shape setup for export in KineFX. This setup is also required to create shapes using Apex. This is the setup which you'll need for the AutoRigger node. The AutoRigger node should set this up correctly, so I'm not going to go through that at the moment. Instead, I'll look at how we can set this up manually. To create the Apex network, I'll need a pack folder node. We'll need an Apex graph to create the rig in. This will be connected to the second input of my pack folder node. This will be followed by the mesh and the skeleton. With the skeleton, we can add this to our geometry with the attributes, but this is not strictly necessary, as we will create the attributes within our Apex graph. So instead of connecting this to the attribute wrangle node, I can connect it to the object merge directly. I can rename these elements. First, we'll have the network. The default name for the network will be base, and I'll specify that here. The type will be .rig. The second item will be my mesh. The default name here will also be base. Since this is a mesh, the type will be shape. Finally, we will have the skeleton. I'll also name this base, and the type here will be skeleton. This will give us our character structure. I can now build the rig network. To begin with, we'll need an input, and we'll need an output. I'll want a couple of value geometry nodes, and I'm going to store my mesh within these. The first port will be for my mesh, and this will be base.shape. The second port will be for my skeleton, and this will be base.scale. I can bring my skeleton in. For this setup, I'll do this using the scripts. Under the rigging script, I'll have import KineFX skeleton. I will refer to these from the object merge node. This will add transform objects based off my skeleton, and these are essentially the controls for the skeleton. These are essentially transform objects which have their rest local position set, and these transform objects are not necessary for the blend shapes, but we do want to be able to set up a basic working rig and have the correct rigging structure. So I have the transform objects, and these will be used to manipulate the rig. We also have the mesh inputs, and I'm caching the values in value geometry nodes. We're setting the meshes within the inputs, but we will also need to set the meshes in the outputs. So first I'll connect the characters mesh, and the output will be called base.shape. For the skeletons, we'll use a setPoint transforms node. This will be set by my skeleton value node, and this node will be used to update the positions of our bones within the rig. The setPoint transform node can then be connected to the output, and the output will be called base.scale. I will not set up everything here, but I will set up a couple of points so we can test. I'll connect the output transforms to the setPoint transforms node. I'll then need to specify the joint names, and these will be for point 2 and point 3. I can then save this and get an animate node, and this should allow us to test to see if the rig is working. And I have made a simple mistake here, as I will need to connect parameters to our input in order to manipulate them. I can test again, and I should have 2 joints, and we should be able to manipulate these joints. We have no deformation, so this will not affect our mesh, but we do have a rig, and the rig is being registered within the animate node. We can now implement the blend shapes. There's a very specific node which we want to find, and this node is not particularly easy to locate. I can attempt to look for the node under the soft verbs, and under animation we have a blend shape node. This node is usable, but it is not actually the node that I want to use. There is a separate node that I'm looking for. We can try and find this node through the menu, but it's very difficult to actually locate. And what we're looking for is actually a KineFX node. If we search for KineFX, we will get some nodes listed, and the node that I'm looking for here is the character blend shapes core node. This node has 2 geometry inputs. The first input will be the mesh with the blend shapes on, and the second input will be the geometry which contains the attributes for driving the shapes, and in this case it will be our skeleton. I'll then need to add the attributes to drive the blend shapes, and these are going to be exactly the same attributes that we created within the attribute wrangle node. However, here I'm going to make them within the Apex network. I'll add the attribute with the set detail attribute value node, and this will be a float version of the node. This node will be connected to the skeleton branch, and I want 4 copies of this node so I can duplicate it a couple of times. We'll need to update all of these detail attributes to have the correct name. The attribute name for these should be the same as the name for the packed geometry, so I can set up the attribute name for all of these nodes. This is giving me an error, but I'll finish copying and pasting the names before looking at that. Once I've set all the names, I can look at the warning. In this case, the attributes are being set on my skeleton, which is connected to the value node, which is connecting to the cache skeleton, and this is not working correctly. Instead, I'll need to connect the attributes and the skeleton branch directly to the output node. So now I'm adding the detail values to the geometry, but we cannot use these values yet as we have no controls for them. To add controls, I'm going to use an abstract control. I'll connect my X value for the abstract control to my output node. I can also set a transform for the abstract control. In this case, I'll shift it to 1 in the X-axis. I'll need a couple of abstract controls. The abstract controls will generally give us 2 screen space directions which we can work with. So I can drive my first 2 shapes with the first abstract control, where I will drive the first shape with the X-axis, and the second shape with the Y-axis. I can set the weight of the third shape with the X value of my third abstract control. I'll raise this abstract control in the X-axis. I can connect my fourth control in the same way. I can test to see if this is working. I should now have abstract controls next to the character. I can test with these. We can also select our abstract controls in the selection set window, and we can manipulate the values with our channel sliders. By default, the abstract controls will go from 0 to 10, and this is not particularly good for sliders like these, as these should be between 0 and 1. So we do get values which are way beyond what we should have here. I can lock these values, but that is beyond the scope of what we're currently doing. My first control isn't connected correctly. I've currently only connected the X-axis to the input. I should connect the Y-axis as well. My abstract controls are working. Because I haven't added limits to these, they are easier to set with the channels, and I can now use these sliders to drive the values of the mouth.